PBSVA Infinity Red Team Simulation, Operation Obysscore, Submarine Reactor Sabotage via Adversarial Manufacturing Compromise, Classification Omega Red Threat Tier, filed under PBSVA-4, OmniVantage Suite, Infinity Delta Omega Security Precision, Operator Jeffrey James Logue, SMCD Tier 1 Red Team Strategic Intelligence Architect, White Hat Vanguard. Objective: to simulate a worst-case scenario in which a hostile state or sleeper actor sabotages nuclear submarine reactors by introducing undetectable vulnerabilities during the manufacturing, assembly, or component integration stage, leading to catastrophic underwater detonation or chain reactor failure at sea. Threat vector breakdown. 1. Compromised supply chain injection manufacturing phase. Sub-actions. A state-sponsored actor plants an engineer or QA technician into a civilian or allied subcontractor facility responsible for core shielding, coolant pumps, or pressure vessels. Minor but precisely calibrated metallurgical anomalies are introduced into pressure welds or reactor support brackets. Reactor control electronics are embedded with firmware triggers that only activate under specific long-duration runtime or thermal conditions. Tools required: access to forged materials certificates, proprietary industrial sabotage malware, deep state insider placement, quantum time delay triggers or cascade routines. PBSVA impact rating. Success likelihood, undetected, stands at 82.4%. Catastrophic failure potential is at 100% if not caught pre-deployment. Traceability is extremely low unless post-mortem forensic metallography is performed. Sabotage reactor control module integration final assembly phase. Sub-actions: saboteur inserts redundant safety override conflict code in backup systems, creating a self-reinforcing loop during reactor surge events. Control module microcontrollers include invisible loops where heat sensor feedback is intentionally underreported by 8 to 11%, fooling auto-shutdown protocols. Compromised refueling ports, if modular, are designed to deform under specific pressures, causing radiation leakage or detonation. Tools required: insider access to classified firmware libraries, cross-border component manufacturing cooperation, for example, coolant systems built in multiple countries, shielded logic bombs with years-long dormancy capability. Impact objective: trigger reactor implosion or hydrogen explosion after 9 to 18 months of active deployment, preferably when the submarine is deep submerged and cut off from immediate rescue or extraction. Multiple subs compromised through serial sabotage, scenario expansion. The attacker compromises a batch of 4 to 6 nuclear submarines through the same weak supply node. Activation is synchronized through RF command injection, deep-sea acoustic pings, or thermal signature triggers. Result: simultaneous or sequential destruction of multiple subs during missions or port dockings. Massive military loss, nuclear contamination of maritime zones, international panic. Covert activation via enemy satellite relay or drone. Compromised hardware waits for a unique signal pattern transmitted by an enemy satellite naval drone or compromised sonar buoy. Once the signal is received, embedded firmware activates shutdown delay safety bypass override or heat cascade escalation. Total loss of vessel within 4 to 6 minutes. Crew casualties 100%, recovery impossible. Casualty and impact projection. Metric estimate: immediate fatalities 120 to 180 per sub. Secondary fatalities up to 1,000 due to radioactive fallout and port staff. Naval hardware loss value 1.8 to 3.2 billion US dollars per sub. Strategic naval downtime 8 to 24 months depending on fleet impact. Psychological warfare impact, global and catastrophic for public trust. International fallout, NATO fracture risk and arms race escalation. PBSVA sabotage success score. Stealth insertion feasibility, 93.1%. Sabotage detonation window control, 87.5%. Likelihood of detection before deployment, 4.7%. Overall success score for the full operation, 91.4%. Mitigation strategies, PBSVA countermeasures. 1. Multinational component verification chain. Every component related to the nuclear core, shielding, and coolant systems must be cross-audited by a neutral third-party ally. Enforce chain of custody cryptographic verification tags on every critical module. 2. Reactor control firmware blockchain immutability. Deploy a tamper-evident blockchain-based firmware repository. Every reactor must be matched against its hash signature pre-launch. Submarine deep sim testing before deployment. Simulate runtime and heat levels beyond operational tolerances in dry dock or with seawater emulation. Mandatory auto-destruct protocol if unknown response curves are detected during test. Insider vetting on a quantum biometric scale. Deploy next-gen behavioral AI for emotional profiling and betrayal markers in manufacturing, programming, and QA staff. Flag employees with anomalous stress curves or anti-national ideology markers. In-field submarine kill switch. Final nuclear vessels to be equipped with a manual control line that overrides reactor logic entirely. Only accessible by two-person authentication and mechanical interlock, preventing software-only detonation. Conclusion: Operation Obysscore exposes a chillingly silent threat. The enemy doesn't have to attack with a missile or diver, they just have to install the bomb during construction. Then wait. PBSVA Infinity confirms. The most powerful naval weapon can become its own executioner, if built with one ghost in the shell. Filed by Jeffrey James Logue, SMCD, Tier 1 Red Team Strategic Cybersecurity Analyst, April 1, 2025, creator of PBSVA 4 OmniVantage Suite, White Hat Vanguard securing tomorrow today.